I'd like to call the meeting to order. We can stand and say the pledge, please. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, everybody, for coming. We have no visitors wishing to speak. We do have some special committee reports, but we're going to switch it up a little bit and do that after the Pathfinders presentation. So we will move right to the superintendent's report.
All right, thank you. Mr. Pigeon is here with Pathfinders to present our Teachers and Students of the Month. So welcome, and we look forward to your presentation.
Thank you very much. It's always a pleasure to shine a spotlight on the wonderful students and staff at Amherst Central High School. We have our November and December Students of the Month here, so we're pleased to present them to you. I also have my wonderful Pathfinder team who is here to present them. I'll allow them to introduce themselves, but without further ado, our Students of the Month for November and December.
Hello everyone, I'm Matt Grams, I'm a junior.
I'm Bridget Smith, I'm a senior.
I'm Ben Nagy and I'm a junior as well.
Sure. Caroline Smith was nominated as a Student of the Month by Mr. Eric Zobel and Mr. Gordon Kroc. Mr. Zobel stated that Caroline's grades speak for themselves, but they do not even begin to tell the entire story of her work ethic, attitude, and character. One tremendous asset that Caroline has is her ability to work with and assist others. Both in class and lab, Caroline is a genuine leader. She isn't always the most vocal, but she asks questions when no one else does and helps classmates with problems. She sets up lab equipment, and she adds an element of friendliness to everything she does. Too often in today's classroom, students do their work just to get it done. Caroline has a nature about her to understand what is happening and then apply what she has learned. She maintains excellent focus with a high level of determination, all while keeping a keen sense of humor and a peaceful mindset. Caroline has handled all of her academic work while achieving unprecedented success as a member of the Amherst Girls varsity swim team. Her leadership and performance are augmented by her acts of compassion and integrity. She is an exemplary young woman, the kind of person I hope my daughters grow to be. Mr. Kroc states that besides being a terrific swimmer, Caroline is also one of my best writers, whether she is writing an essay on a short story or writing a poem in the style of the Gawain poet. She is also smart and articulate in her comments in class. She is very good at seeing how a writer does what he or she does. Congratulations, Caroline. Your honor is well deserved. Congratulations, Caroline, for being chosen as one of November's Students of the Month.
Jacob Reinhardt was nominated as Student of the Month by Miss Christine Sullivan. Miss Sullivan states that whether in the classroom or not, it is clear that Jacob is a young man who puts great care, attention, and effort into all that he does. When Miss Sullivan's 5th period English class noted with concern that a classmate had been out for several days, Jacob approached Miss Sullivan completely independently and volunteered to deliver any assignments his classmate had missed so that his classmate and neighbor wouldn't fall behind in class. Miss Sullivan applauds Jacob for recognizing where he could step up to help another with his act of kindness and altruism. Well done. Congratulations, Jacob, for being chosen as one of November's Students of the Month.
Congratulations, Jacob. Good luck to you.
Sophia Roy was nominated as a Student of the Month by Miss Juliana Curtis, Mr. Robert D'Annunzio, and Mr. Dennis Bauer. Ms. Curtis stated that Sophia works extremely hard as an independent study student. The independent study course is only available during Ms. Curtis's study hall, so Sophia is very flexible in that environment as well as patient. Currently, Sophia is working on a painting of 2 bridges coming together that requires a great deal of attention to detail. She's such a hard worker in and outside of the classroom. She runs track and field and seems to manage it all. Sophia really works harder than any student that Ms. Curtis has ever had. Mr. D'Annunzio states that she is a very quiet student. However, she's a very smart student who is always punctual and respectful of others. She always has a smile on her face. Mr. Bauer states that Sophia consistently does high-quality work in chemistry class and lab. Mr. Bauer attributes her success to her excellent listening skills and her positive attitude. Congratulations, Sophia, for being chosen as one of December's Students of the Month.
Get a hug.
Thank you.
Congratulations.
Stephen Quinlivan was nominated as Student of the Month by Mr. Gordon Kroc, Miss Ann Ward, and Mrs. Stephanie Radine. Mr. Kroc states that Stephen carries on the proud legacy of the Quinlivan brothers before him. He's an outstanding citizen of our school. Mrs. Ward states that as his advisor on the academic competition team, she has gone to put Stephen's wide breadth of knowledge to work in different ways from the classroom. As his team who won Western New York B and Bowl and the Masterminds League Championship, he competed nationally at a tournament in Washington, D.C. She was able to spend time enjoying Stephen's wide-ranging reading habits and interests. Miss Ward has come to value his opinions on whatever book is by his side and enjoyed his sense of humor as they spent long hours together on buses and waiting for things to happen. Stephen is unfailingly polite and is often the first on our team to extend a hand in congratulations to the other team, generally after surprising them with his breadth of knowledge of fields from chemistry, resonance, structures to speakers of the house. He is truly one of the most interesting students she teaches. Mrs. Radine states that Stephen is very strong academically and he is also very personable. He is a willing participant in the class and she is always willing to help out. Stephen works very well with other students and will often be seen helping or coaching his classmates through difficult problems. Stephen is an absolute pleasure to have in class and is an excellent candidate for the Student of the Month. Congratulations, Stephen, for being chosen as December Student of the Month.
Thank you very much. I might add, Stephen brought home the championship in the History B and Bowl this past weekend. We had an Amherst head-to-head match. We took the championship at both, and we ended up playing our A team and our B team for the championship. So congratulations to them. Mr. Jones sent his regrets. He had a family conflict, so he wasn't able to make it tonight. He was the November Student Teacher of the Month. And Mr. Cyrek would have loved to have been here, the December Teacher of the Month, but he's representing us at Paris Island, South Carolina currently, and he was invited for a special educator program for the United States Marine Corps. So he's currently in South Carolina representing Amherst High School. So thank you for the opportunity, and thank you to the Pathfinders.
Very nice, well done. Thank you, parents, also for all your support of your children. Without your support, they certainly wouldn't be able to shine the way that they do. Up next in the superintendent's report, we have representatives from our middle school here to talk about our first year of implementation of Project Lead the Way. For the board members, you may recall last spring we did a presentation proposing to add this program, and there was some significant upfront costs to get it up and running relative to training and materials, as you can see as the folks are setting up here. But I think what you'll see tonight is that the program is up and running, and you get to see some of the great benefits of it right here in front of you today at our board meeting. Mr. Griesmer?
Bear with us one moment as we get our supplies out here. We are close.
Which I like. I don't think anybody would be but we do that. We have to ask them. That's fine. We can do that too. I think last two more.
We got all the toys.
We got those ones. Halfway there. Good evening, everybody. Thank you so much for giving us a chance to come in this evening to give you an update on our Project Lead the Way initiative. We are very excited to be here. You know, last we spoke, we were speaking about the possibility of doing this, and now it's here, and we're a few months into it. And fortunately, I have some wonderful co-presenters here this evening, including our tech department and six wonderful student helpers. So that is really fantastic, and you'll get to meet all of them as the presentation develops. Mr. Crombie, if you would, get us started. Before I turn it over to Mr. Karras, I just want to remind you how we structurally were able to pull this off. We have quite a few supplies that go with these courses, as you're starting to see. What's behind you, I should point out, is one of our supply bins, if you will, for automation and robotics. And if you get a chance to come take a look, there are some pretty intense pieces there that our students are working with. But so to do it properly, we have Mr. Karras and Mr. Shupp combining to do design and modeling in the first semester for all of their 7th graders. And then halfway through the year, those supplies will go over to Mr. Curtis, and he'll do that with all of his 7th graders. He right now, with his 8th graders, is doing the other course, and that'll flip-flop halfway through. And when a particular grade level doesn't have one of the Project Lead the Way courses, so the opposite semester, you'll recall we said they'd be getting the traditional, long-standing, and very fine Amherst Technology Department curriculum that pre-exists Project Lead the Way. So it's really a win-win in all regards. And I'm going to turn it over now to Mr. Karras, who will talk about some summer work they did, design and modeling, and then he'll bring it over to Mr. Shupp.
Okay. Good evening. My name is Mr. Karras, Technology Department. I want to thank, on behalf of the Technology Department, we would like to thank the Board of Education, Superintendent Pinella, and Assistant Superintendent Dr. Schoenfeld for investing your time, energy, and money for the first-rate program such as Project Lead the Way. Our summer training, what we went through. Our training program was held at Rochester Institute of Technology with between 250 to 300 teachers in attendance. It was very well structured and organized. Each course we took is a 10-week class in school. Okay, 10 weeks in school. And what they did was they condensed it down to 5 days for teaching us. So, need I say that it was hairy, to say the least, but good. Because it was so very vigorous, we all agreed that we learned the useful material and could use this information to substantially enhance our students' ability to problem solve and write code. We have already seen benefits such as our students are exposed to different types of drawing methods, problem-solving activities such as the foot orthosis, which we're about to show you, the puzzle design cube, programming the Cortex for our robotic projects have expanded students' critical thinking skills. Proficiency at using measuring tools, not only for engineering and architect, but also for everyday use. The ability to write code, install motors, gearing, and wiring sensors that today are used in a wide array of business.
So, at the start of the year, to begin our 7th grade design and modeling course, the first thing we did was the orthosis project. Students were put into groups and challenged with designing a foot orthosis or a brace for a child with cerebral palsy. Students were given a design brief containing design constraints and criteria that their orthosis must adhere to. And we watched a Project Lead the Way orthosis project introduction video. That was it. We turned the students loose and watched them soar. Students had to collaborate with their groups and persevere through roadblocks that they encountered. We were a little hesitant at first to begin the year in such a way, but we were amazed by what our students were able to accomplish.
Okay, so our design and modeling, this was one of the programs we took. And what we did was we started off, as Bill had just said, was the foot orthosis. So here today are 7th graders, Rebecca Grande and Natalie Testa, to explain more about the different projects in front of you. Please. Just grab one of them and just explain what you did.
So, for the foot orthosis, we had to design the aspect so that their toes wouldn't be pointing down, and it could still go up, but they wouldn't be able to go down.
There were some challenges, like some of the materials would break, or it would be able to go up. It would be able to go down. It would stop it from going down, but it would also stop it from going up. So it was kind of trial and error, and we just had to see what worked.
We had to make sure it was removable too, so they would be able to take it off when they went to sleep and everything. So,
Did you guys have any challenges?
At first, we all had to decide what kind of design we wanted to do, and in groups with more like leading people, I guess you could say, like they all wanted their own design to be shown, and we all had to compromise.
We used a little bit of each other's ideas, and if it didn't work, we took it apart and rebuilt it.
There was a lot of that too.
What about the materials you used?
All the materials that we used were pretty much found in the classroom, and it was mostly compiled of duct tape, different cardboard, and string and objects like that. And a lot of the stuff we had to bring, some of the stuff we had to bring in ourselves, but we tried not to do that so much.
It was harder to make because we actually researched them, and the materials that people were using professionally were like plastic, and we didn't have any of that. So we just had to find what worked.
And then at the end, what did we do? What was the final end project? once
We
we
had
made it?
to present, and so we made sure that one of the people in our group who was going to be like the presenting person, it would fit on them and they could show how it worked, and then they would explain the project and what they tried to do during it.
Awesome. Great job. Good job. Thank you very much. Walk around, maybe just show them a little closer how it works.
Yeah,
great.
They used string to make it so it could go down, but it could
The
still
ribbon we
bend
brought
backwards.
in so we could make sure that it fit, and that we would, and it would like adjust to whoever's foot was on.
That's very practical.
Yeah.
And these are currently on display in our library media center. If you have the chance to pop on by, display looks fantastic.
To make sure that it was secure on them, and this kind of prevented their legs from moving that much.
And
this stuff was in the room? You had
No,
this
we
thing,
had
some
to
of
bring
this?
this, and we brought in the stuffing, but everything else we found in the room.
Velcro, and they made it more
It was nice
secure.
of you to make it more comfortable. Some of them didn't look very
This isn't-
comfortable. I saw them in there when I was there for the book fair.
We brought in our own ribbon and stuff out to make it more comfortable, and this would be snug, so they could adjust it as whoever's chosen them to.
Seems like we could have used that a
I,
couple months
listen,
ago.
a couple years ago, I was in those type of things.
Well, thanks again, girls. Fantastic
Nice
work.
job.
Good job, lady.
All right, so moving on. Within the design and modeling course, students have learned various engineering skills, such as drawing objects in isometric, multi-view, and orthographic projection form. So here is a student example of a properly drawn and dimensioned orthographic projection drawing. This entire drawing is called an orthographic projection. It consists of an isometric view of an object in the top right, and then 3 different multi-views of the top, front, and right side, along with the overall depth, width, and height dimensions on the multi-views. Along with using traditional rulers to measure items in inches and centimeters, students were also introduced to dial calipers used to measure items to the nearest thousandth of an inch. So please give a round of applause for Tigers Zaria and Ireland, who volunteered to help me out. Okay, I need 2 volunteers. Just take. Now don't all raise your hand. All right. Or you can stay where you are. Just 2 volunteers. Okay, perfect. So what you guys are going to do, Azaria and Ireland are going to help you out. You guys are going to try to measure the thickness of a penny to the nearest 16th of an inch. The girls will help you out.
I want to kill him.
Try to measure that penny.
Okay.
Thickness of it to the nearest 16th of an inch.
Thickness?
Yeah.
To what, how to measure?
Okay.
1/16 of an inch.
Ta-da.
Done.
I was right.
It was a race apparently.
Our measure big
Competitions everywhere.
But, okay, so that was alright, right? But it turns out there's a special tool called a dial caliper, which would be a ton easier. So, just show them how to do that.
I'll let the volunteer
We're
know.
using it at the end.
We could just put it in and we can measure.
Okay.
So, how do you
My finger.
So this is the decimal point.
Mhm.
So 0 somewhere. So how many full numbers are the largest one number for the 0?
0.50.
So 0.054
The nearest dollar. Yes.
So, that
Would be
is our measurement. So
0.
0.54 inches. It's pretty close, pretty small number.
That is.
A little easier than doing the 0, right?
7.
Okay.
Probably, so 0. Write down just to show you 0.
0.057.
0.057. So 0.057 inches. Pretty kind of number, right?
Yeah.
Hey, Ireland, can I
Can I
see
hear
that?
5-4 over there?
Yeah, so there's some
So
difference. So there's
manufacturer, do you have that much variance? You get a variance in the manufacturer?
Yeah, I'm sure like anyways, the stuff on the
part?
pennies, like, you know, 50s and
Extra.
smash.
Extra finger grease?
Cool.
And it's worth pointing out that, while we've had robust technology programming here for years, we have not had calipers in the building. And as it relates to STEM fields and engineering, as you can tell, this is a pretty appropriate tool to use. So already, another check in the great column for bringing this on board.
Yeah, so as you can see, using this special dial caliper tool makes measuring small items with precision much easier. So, again, thank you girls. Thank you guys so much.
And for the design and modeling, the culminating project is what's in front of you right now, which is the cubes. And this is basically the problem design brief that we presented to the kids. They have to use 27 cubes. We have to make, out of the 27 cubes, we have to make 5 parts. The parts cannot look the same. 2 of the parts must be at least made up of 6 smaller cubes, and it cannot be any smaller than 4 cubes each, and they must interlock. So this is one of these problem-solving, really intense programs where they sat down and we launched it right away, and we just said, well, this is what you're going to do, here it is, and we started with the plastic pieces, and I'm going to have, once again, Rebecca Grande and Natalie Testa to explain what has been happening in our classrooms.
So we started off with these plastic cubes, and we could organize them by color so it was easier to see. And we put them together so that eventually they would all fit.
And after we did that and we got checked by Mr. Karras, we would glue together wooden cubes, and that would make up our final cube. And we had to make sure that no glue was on the outside and it was all even, so it would be able to go together.
There are a lot of difficulties, like you think it might be done but you forgot one of the rules, or it didn't go together properly. And you couldn't really see the different colors in the wooden cubes because they were just all brown.
Yeah, kind of like along with what you were saying, we had a lot of long breaks due to weather and stuff like that, and Christmas and everything. And so in our class, a lot of people eventually forgot how to do their cubes, so they all had to start over.
After we finished putting together the wooden cubes, we would draw them out, and we would make the isometric, like that. We would make an isometric view, where you could see all the sides, and then we make a 3-view drawing where you could see all the sides individually.
You want to show them your drawing?
Okay. So, like, I cut out my isometric drawing, which I drew out in 3D. And then after that, we had to do top view, front view, and right side view, which was top, front, and right side. And then here was another one, which was a little bit more complicated. And how we draw it is 3 little like square things per side of the cube. And yeah, pretty much it.
Why 3?
Because that's the measurement of the cubes.
Right. The cube is how big?
3 by 3.
3 by 3, but what are the squares? How big are the squares on the isometric paper? Quarter inch, right? So those are 3/4 inch wooden cubes, and that's why you're going across 3, right? Okay. Good. All right.
Good job.
All righty?
Very good. I think it's safe to say that during a professional development session, didn't we give this to some of our faculty and staff? And they struggled mightily in putting the cubes together, but it just shows that our kids did great work when grouped together and trial and error, and again, making the STEAM process come alive, because you can clearly see the overlap with math and science and engineering, trying to put something like that together. Great job, girls. Thanks.
Well done, ladies. So to kind of wrap up the design and modeling section here, the Project Lead the Way design and modeling course introduces important skills that are used extensively in the fields of architecture, various kinds of engineering, and manufacturing design.
Now Mr. Curtis will talk about automation and robotics.
Before we get going, let me give you my 2 cents on the cube project. Really difficult. We did this in our program, in our time that we were there. This is the one that I created. I did all the drawings, got it all set, ready to go, got it made, put it together once, put my drawings away, took it apart, couldn't get it back together. It's very difficult. Once you've designed it, now you have to put it back together. And I was the one that designed it. Just on a whim, 2.5 months after we took the class, sitting on my desk still unattached, I said, I gotta put this back together. It went back together. It's just luck of the draw, I think, on that day. But that's a very difficult project to not only design it, but then to put it together.
Feel free to pull it apart. I mean, they're color-coded. That's what we try to do to help you out. It's just if you do want to pull it apart, that's fine. Just it works a lot better that way.
Everyone's going to be playing with it instead of the rest of the agenda.
All right, so my task is to start to teach the automation robotics unit first. And it's a different type of thinking. It's mechanical thinking. You know, here at school we spend a lot of time thinking about how to write something and this, that, and the other thing. This is mechanically putting things together with small parts and pieces. And so we started out by giving a little bit of history of robots and different types of robots. And there's a lot of different types of robots that are out there. And so the students had to do an actual presentation report and give it a presentation to their peers on their type of robot. They could have chose from service type robots to manufacturing type robots and all kinds of different types of robots. They got to pick one and actually did a presentation on it. After that, we moved on to types of motions that robots can actually do, whether it's rotary, linear, oscillating, or reciprocating. And then we moved on to the mechanisms and gear ratios. And you can see on the bottom of our PowerPoint there's a little bit of math involved when it comes to calculating the gear ratio between different gears, whether it's designed for speed, whether it's designed for torque, depending upon what the end purpose is. We went through all that math process. And so we have rotary and linear and all kinds of other stuff on here. So Torrance and Gretchen, please come on up and welcome them to walk you through the mechanisms that we currently
Okay, so the first mechanism I have here is a simple gear train, and it is used to mesh the gears, and they turn 2 different ways. And here is the same kind of train, but instead it has an idler in the middle, and it is used so that the input and the output go in the same direction.
Is it possible to change the gear ratio on those?
Yes, you can change the gear ratio by changing the size of the actual gears. So since the input is larger than the output gear, this is used for speed.
And so this is the bevel gear that we used. It's mainly worked to change the angle. And this is the input and this is the output.
Could you change the gear ratio on that one also?
I think so.
You can.
Yeah.
Is there a gear ratio on there right now? Is it constant?
Yeah,
It's constant. How come?
because they're both the same size.
Both the same size. So anytime you use 2 gears of the same size, it's a constant. There's no speed or torque increase or decrease.
This one is the Werman wheel, and it is used to change the angle of the actual gear, and it is also used for torque. And so when you spin this around once, this only moves over 1 tooth, so it's not very fast.
So is it designed for speed or torque?
It's designed for torque.
It's designed for torque. And I do have to say, we did calculate the gear ratio on that. Do you remember what it was?
Is it?
If one goes one revolution here and it goes 1 tooth, and there's how many teeth in that gear?
I don't remember the number of teeth.
It's 24. So the gear ratio is?
Wouldn't it just be 1 to 24?
Yeah, 1 to 24. And there's videos out there where they have monstrous floodgates with one person with a crank arm like this big, just cranking it in the air, and the thousands and thousands of pounds being moved by one guy or girl going like this. Huge amount of torque increase, so it's a huge mechanical advantage. Very good.
And so this is the lead screw. It's for, well, this is the input and this is the output here. And
What's the type of motions that are on the input?
rotary,
Rotary, and the output is?
linear.
Yeah. So you can change it from rotary to linear depending upon what you want that output motion to be. Nice.
Okay, so the last one is also rotary to linear. And when you move this in a circle, the output moves back and forth, which is the linear motion. And it is used on a steering wheel, like for a car, you steer the wheel, and the wheels move and tilt the way you steer the steering wheel.
Great. Thank you guys very much. Appreciate it. So once they've learned all the mechanisms, then they move on to, I think, the cool part of it, which is the robot. It's called the Clawbot. And basically, this is something that they're going to build. They'll build it in teams. We have 12 of these. They'll build them in teams, and then we get to spend time programming it with Robot C. And it's a C program that we use for it. What you have here is in here, which is the application of it. So if you look here on the side of this, we have an input and output. Well, actually, the input's on the idler gear, so you have 2 outputs, but the idler gear causes both gears, input and output, to spin in the same direction. So it goes forward and backwards. Also on here, there's a small gear to a large gear, so there's a lot of torque on this one. That could be redesigned. This opens and closes, and the possibilities here are huge. You could put 20 different motors on here, 5 or 6 different sensors, whether it's a bump sensor, whether it's the line tracker. We're going to get some optical sensors on there to actually create it and do whatever you want. So that being said, once they create it, now they actually get to program it. So the first program that they're going to do, you never know, tech never goes right. Well, sometimes. Careful on that. Seems like a very simple project. All they have to do is squeeze the bottle, pick it up, move it forward, drop it down, open it up, back it up. It's repeatable over and over again. To do that, it takes 20 different lines of code just to do that simple program. but what we're going to teach them. And if you talk to any engineer that does any type of manufacturing program, that if there's something down on the line that's not working right, they have to read through millions of lines of code to figure out where the problem is. And that's a big problem because it takes a long time. I talked to an engineer not too long ago who was reading through 2 million lines of code and finding the problem. He's been there 2.5 weeks. Still can't find it.
And it may not look like much on the projector, but that is what they'll ultimately have to do. And I believe there was a little more than a page of code for our students that they'll have to write appropriately to make it do what Mr. Curtis will soon make it do.
So basically, it starts out with a blank, and they literally have to type all that C, C++ programming in. So we'll give you a demonstration. If I was a designer, I'd change that on-off switch to someplace else. It's hard to get that. But anyway. So we have bump switch sensors here that we're just going to turn it on, and it should work. It has a wait time to it. Then it goes forward. Drops it off. It'll wait, because we're telling it to wait a specific time. Wait again, and then it looks like that. The cool thing is, if I do it again, it's repeatable. Not yet. So, really, really simple, but for me, looking at this, the sky's the limit, because as soon as they can master that, they can change the claw so that not only does it come up at an angle like that, so you spill your drink or whatever you're picking up, you can actually rotate it so it's like a wrist. They can add other motors and sensors on here to do whatever you want. So the sky's the limit when it comes to that. As far as jobs go, let's face it, everything today is manufactured and it's all automated. Very few people work on the manufacturing line. If you watch a video online, there's nobody working. It's all robots. And we need people that are going to program it. And this is the first start of understanding the program language in order to get that done. Aerospace and defense is another place. I have a friend that writes code for the military, and that's what he does all day long. And he makes pretty good money doing so. And so I could read it all day long, but there's a ton of different jobs. And I'm so excited to show the students what their possibility of what they could do for a living and actually have some satisfaction.
So who programmed that?
Mr. Shupton. With Project Lead the Way, there's a lot of background work that has to come into this process. We are just starting to get into that. So now that these are all done and built, now my after schools and nights and weekends is thinking of things that the students can build with that and writing it so I know it works. And then working it through with them to make sure it programs right. So it takes a long time. Biggest thing is, Mr. Curtis, I know it's going to come. Mr. Curtis, my program's not working. How come? I don't know. Read the code. What's it say? Oh, you told it to go this far, and it should have been, oh, you have the motors backwards. They have to be in opposites. So we can hit them through it, and then it's problem solving. If it doesn't work, you got to make it work. And the biggest thing that happens to me a lot at the high school is, how come this doesn't work? I don't know. They hate when I say that because they know I'm not going to give them the answer. I'll give them hints. All right, I'll be back. And it's really kind of so. I'm looking forward to that. It's going to be a lot of fun. That being said, VEX competitions are out there. There's a huge amount of VEX competitions out there as far as competing for different designs. They give you a criteria of what you have to do and what the limitations are and restrictions are, and you compete against other schools. It's out on the area, but it's also nationwide. It's kind of neat. So, that being said, turn it back over to Mr. Crombie.
Thank you, Mr. Curtis. So, ladies and gentlemen, in closing, Project Lead the Way adheres to the middle school philosophy by offering stimulating activities that cultivate our students' critical thinking skills and problem-solving skills. In addition, it provides the opportunity to grow emotionally by experiencing success in emotional success and academic success in the STEM arena. And as our program evolves, and Mr. Curtis alluded to it moments ago, and our student capacity increases, we want to continue exploring further opportunities, possibly a new course such as coding down the road, exploring opportunities to compete in these local VEX competitions, because it would be an amazing experience for our students to kind of showcase their skills that are grown here in Amherst. Courage is one of our Tiger Care tenants at Amherst Middle School. And before we wrap up, I believe Rebecca, Natalie, Azaria, Ireland, Torrance, and Gretchen demonstrated courage tonight by coming here tonight and being student volunteers. So let's give them one more final round of applause. Great job, ladies. Thank you. And we as a school, exclusively this department at this time, we are continuing to look forward to working alongside all of you to maintaining that standard that Amherst Middle School is the best around. And as a token of our appreciation, we understand that collaboration is key to our success. We have a small trinket, if you will, that was designed and printed in one of our 3D printers. We have a key magnet and or keychain. You can choose which one you wish to take home with you tonight.
Thank you.
Take both. We got as many.
Tough choice.
We can print them out all day
Oh,
long.
all right. I didn't realize we were
Take as much as you want.
So again, thank you very much. We'll field any questions if you have any, and we'll start to clean up.
No, well, I think that's off the list.
Any questions for us?
Don't be shy. Sure. You guys can take one. I'll come back to you. It looks like your hands are good. Great job.
Thank you.
You're welcome. Wait, don't give me your hand. Go back. Keychain.
Is there only one
This, yes, only one way to do it.
Thank you.
But not for all of them. Depends on how you design it, right?
Oh, that's right. You were busy up there cleaning up a shop.
Whatever, as
Thanks,
long
guys.
as
Well
it's
done. Proud of you guys.
I mean, thousands of different possibilities.
Yeah,
But for your specific design, only one way to yours was better.
Can I help you, sir?
They had a scavenger hunt.
Thank you very much.
Thank you, students. Appreciate it.
One of the things was putting one of those together in a certain amount of time. I'll take it. Yeah.
That's really cool.
Yeah, it was fun, but it's hard.
But one of the things
We
that,
didn't get the blocks together, but we were in the top three.
one of the things that you'll notice when folks talk about, economic stimulation packages, the Buffalo Billion, even the State of the State address recently delivered by the governor, is that there is a serious concern by policymakers that there won't be a workforce that will be able to keep up with the technology as it evolves. And I think, this demonstration shows that it's really incumbent upon us as a school district to make sure that we offer opportunities for kids to have exposure to these type of career opportunities so that down the road, if they decide they'd like to specialize, they can. Certainly, we're not going to have them walk away knowing everything they need to know, but to have a little bit of coding, so the problem-solving, creative thinking, the flexible automation, it's beneficial to our kids. And one of the things that statistically you see is that women are underrepresented in the STEM-related careers. And what's nice for me to see is that all of our student, demonstrators here tonight are representing our girls in our middle school. So that was fantastic to see as well. So the other thing I mentioned before we move on to our committee reports is Dr. Schoenfeld was quiet during the presentation, but certainly he did not take a back seat in the implementation of this program. He was right at the forefront of it, so he deserves a lot of credit for the successful implementation we've had so far. So thank you.
You're welcome. Thank you.
That's the end of the superintendent's report.
All right, we're going to backtrack and go back to a report of special committees. Besides technology, do we have any other? You have one as well, okay.
Do you want to go first? Actually, it's a good segue for me because mine was the technology committee, and that was a
You're on the agenda.
pretty
Go first.
impressive display of our technological movements in the district. So the technology committee met this past week. It's a 20-member team representing teachers, special education, library media centers, the technology department, administration, and of course a board parent member. It was our first meeting of the year, so a lot of the time we spent was procedural and figuring out what our tasks were going to be. The representatives from the various buildings will be coming armed with positive work being done within their buildings in the future. There's a new district website. Hopefully everybody's seen it so far. If you haven't, please check it out. It's pretty sleek and it's easy to navigate. If you do come across any issues, there's thousands of little links, so it's possible that some of them don't go exactly where they're supposed to go yet because it's a new website. So let somebody know if you find anything that needs to be fixed. The other thing you'll notice, and you'll notice with our agenda, is that a lot of the pages have been changed. The appearance of them has changed. We're making sure that everything is ADA compliant. And in order for that to happen, the PDFs have to be legible by like e-readers for people who are sight impaired, that kind of thing. So the formats on a lot of the pages had to be changed. And then every time someone outside of the core group who are in charge of the website has a page they want to go up there, it has to be made to be ADA compliant. So, it presents challenges, but obviously those challenges are worth confronting. We were given a presentation regarding IBM Watson for educators. Presented to the Amherst Central School District educators for the first time on Thursday. The progressive technology of artificial intelligence will be used in the near future to enhance teaching and learning. The technology is projected to be in use in schools within the next 5 years to personalize learning. Central Office is considering the opportunity to pair up with IBM in an effort to be at the forefront of this developing technology. Amherst Central School District would be only the second district in New York State and one of 25 districts in the nation to be trailblazing with this inevitable technology. Members of the team shared pros and cons, which will help with the next steps. The presenter who, it's obviously a really cool technology to hear about, generally it's being used in the medical field at the moment, and the amount, I forget, he said that the Watson can read something like 500,000 pages a nanosecond or something. I might be exaggerating slightly, but not by much. So it's pretty robust technology, which could learn along with all the information that you give it about how a child learns and help us better address the children's needs going forward so that we can teach to their needs as opposed to just teaching them and expecting them to adapt. I mean, you want both things to happen, obviously, but it's pretty dynamic technology and it's very interesting. Through a modified Kagan brainstorming experience, we used a post-pile and repile procedure where we were able to organize and group final draft of 6 action steps for instructional technology and 7 action steps for professional development. Obviously, having all these diverse perspectives, there were a lot of really interesting ideas, but we were able to, through the guidance of the good doctor, we were able to figure out a way to come to an agreement on what priorities should be tackled. And then the group also brainstormed on what potential obstacles could impede accomplishing those action steps. The next meetings are that was the January 4th meeting. The next meeting is March 20th, and then we have another meeting on May 16th. And Dr. Schoenfeld will be putting together a technology newsletter with updates, including a photo of all of the attendees with our smiley stickers that we use to vote. So it was a very productive session to put 20 diverse perspectives in one room and come out with the amount of actual collaboration that we do is Dr. Schoenfeld does an excellent job of corralling us and helping us focus in the right direction. So, thank you.
He's good at herding cats.
Yes, that's a good way to put it.
Mr. Smith, you had a report?
Yeah, last Thursday night I attended the Erie County Association of School Boards Budget and Finance meeting. If you recall, last Thursday night, the weather was heading south, so very sparsely attended. I won't say a brave few since I was there, but a brave few made it out. The highlights were the executive committee has given Dr. Frazier the authority to move ahead with this. I talked about it last time, this 1.2 full-time equivalent idea, where Dr. Frazier will be compensated at 0.8 of an FTE, and then there'll be an incremental 0.4 of an FTE, with the division of duties being Dr. Frazier's 0.8 will focus on revenue opportunities, and yet to be hired 0.4 will focus on advocacy. So that led to a first presentation of the draft budget, and it is about 2% in the negative, but that's being driven predominantly by this increase in the salaries. So, but again, it's the first draft, and as Budzinski knows, the first draft of any budget has a lot of movement yet to occur. So there was a lot of discussion around the budget, but I think it was premature discussion. The other highlights were Commissioner Elia has agreed to come to next year's August 23rd meeting. Right now, the invitees are superintendent, board president, board vice president, but because of her presence, Dr. Frazier's trying to figure out a way to open the attendance list a little bit more, and the commissioner's interested and willing to be in a room with more people than the 3 leadership roles from the district. I'm thinking it was a very quick agenda because people want to get in their cars and get home.
Can you suggest a bigger room?
Where have they been historically?
I have no idea.
It's, the last 2 years, it's been out at
The columns.
the columns out there in,
Seneca on Transit,
I don't think I've ever been in that property.
behind Alphonse.
Oh, yeah.
The new banquet facility.
Okay. Yes, I guess I can suggest a larger. I mean, Dr. Frazier's thinking about it. He thinks if we're going to have the commissioner here in town, let's have as many people we exposed to our thinking as possible. So even historically, the invite list has been those 3 leadership roles. So I'm sure at the next meeting we'll hear more about it.
Mr. Smith, could I ask you, does that 0.8 and 0.4 make sense to you? It sounds kind of awkward to me, I don't know.
You've got the presenting work that they were going to focus on, this revenue generation role by Dr. Frazier and this advocacy role by yet to be determined. But the other idea is it creates a succession plan for Dr. Frazier. So it might appear, and Dr. Frazier would argue very aggressively that there's things that aren't getting done now that incremental labor will help with, that it's also to present any sort of a disruption to service to the member districts if Dr. Frazier exit for whatever reason.
But 0.4 is an awkward amount of time for someone to work in.
I mean, my take is Dr. Frazier will work 4 days a week. It gets in his 0.8, and new individual will work 2 days a week. That gets in their 0.4. So more to follow.
any other reports? Okay. Then we are going to need a motion for new business.
I can make a motion for approving new business F1A through D and 2A through K.
Do we have a second?
I'll second it.
Do we have any discussion? All right. All those in favor of approving new business items F1A through D and 2A through K, please say aye.
Aye.
Opposed? Motion carries 6-0. Ms. Budzinski, do we have any follow-up action items? Okay. Then we will need a motion to convene an executive session.
Before we do that, could I just call out the Boy Scouts that are here?
Oh, please do.
They're here, I assume it's for the citizens of the community?
Correct.
Yeah, here learning about our process and how things work.
Perfect.
So welcome, Troop 261. They meet here on Thursdays in the cafeteria.
Wonderful. Welcome.
Welcome.
Thank you for attending. All right.
Sorry. I'll make
No,
a
that's
motion
perfect.
So we convene to executive session for matters regarding employment of a particular individual.
we have a second?
Second.
All those in favor of convening to executive session, please say aye.
Aye.
Thank you, everybody, for coming.